Welcome, everybody, to another BobCAM live event. My name's Andrew. I'll be the host today, and we're going to be taking a look at the two-axis mill for the Solidworks plugin. Now I'm going to give it a couple minutes for people to kind of pop in, and then we will get going. There we go. Hide that overlay so we don't have the black box in the background. All right, we'll get started here in just a couple minutes. I just wanted to give some people a chance to log in. We'll get started about 5. Maybe even a little bit less. All right. Well, I haven't seen anybody else get added to the event so far, so we're going to go ahead and get started. So again, my name is Andrew. We're going to be going over the SolidWorks plugin for CAM, the two-axis CAM. A couple things I wanted to touch on first. First thing is the plugin. So once you open SolidWorks, if you do not have the plugin enabled, you're going to want to go to the gear, and if you click on the drop-down menu, you can go to add-ins. And then you should have the gold partner add-ins where you can enable it. You can also enable it on startup. Once I do that, any file I have that I open will have the BobCAM wizard. So let's go ahead and take a look at a file here. We're going to go with something very simple to start, and it's something that everybody has installed with their software in our data folder. Now, the reason I'm using this is I'm just going to kind of show some examples of different ways to pick geometry. One of the things that's beneficial about the SolidWorks plugin is the power of using their feature tree. So in the SolidWorks feature wizard or feature tree here, we have the regular feature manager and their regular tabs. And then we have these three tabs that we add. So you have your data entry, that's for probing. You have your CAM tree, which is going to have your CAM tree, your operations tree, your tool tree, and your posted window. So whenever you have posted code, it populates here. And then you have your Bob Art Manager, which we're not really touching on that today. So we're just going to be in this CAM tree. Now you should also have a little tab that pops up. If you don't, you can right click these and go to tabs and add in your own. I have my BobCAM tab on, so it is displayed. You can always edit those tabs and change what's on them. Now there are some settings, but there's not a lot here, but we'll kind of go through them a little bit. So you have your data folder, which you don't want to change. We do data collection. So if you're using a Pocket, we see that. We don't collect anything other than the features being used. So we know how to better improve in the future. For your browser, you can use the online help or turn it off, or use the default browser, or just use Edge as your default. User interface, you can change the tree behavior from double click to expand and collapse or edit. And then your CAM settings, we have these enable CAM tree flyouts. We're going to talk about those a little bit today, quickly changing speeds and feeds and things. Auto blank new items, which I typically like to have that on, but for training purposes, I leave it disabled. And then you have this new look and feel. So if any of you used previous versions of our SolidWorks plugin, some of this is all new. So you have an extended or classic feel. Now the extended is going to have status icons for posting and whether something is hidden or shown. We're going to keep it on extended. And you're just changing here the status location, whether it's on the left-hand side or the right-hand side of that wizard or the tree. I like to keep it on the left just for training purposes. You can change your posted font now. Your simulation window can be an embedded window, or you can do a separate window now. So for those of you that are familiar with 35 or have watched those videos, we have the same functionality here. And then our operation tree, I actually want to turn on this display feature name. I kind of like that. And then you have your current document and document defaults. Now these are going to be your tolerances. We're typically going to 1/10 of a thou for 2-axis milling, 3-axis 5/10. You have your simulation tolerances and your default machining order. So it's good to understand the default machining order, but you can change the machining order in the operations tree, which we're going to take a look at that a little bit today. So there's not much more for settings. So let's just go ahead and hit apply and OK. And I'm going to go ahead and start a new job. Now I can come up to my BobCAM tab and go to new job. You have new job under this little quick access toolbar here on the left, or I can right click CAM defaults and go to new job. So I have the start stock wizard enabled to start up. And I'm going to be using, let's go just with a Haas 3-axis mill. So I'll select my solid body. Now I don't really have to do this. I'm not drilling anything. And I don't have a fixture here, so I don't need to differentiate between the model, but it's just a step to pick your solid, then you hit next. If you do have a fixture, it helps us differentiate where the part is versus the fixture. So keep that in mind for that work piece. If you like to work in assemblies, which we're going to take a look at today, you can. Now my stock type, I'm going to leave this pretty default. I'm not going to go too crazy on this one, so we'll hit next. And I'll leave the origin where it's at in this upper left-hand corner. So we'll just click the green check. Now the nice thing about the SolidWorks plugin using the feature recognition is you can come in and go to a mill 2-axis operation, select geometry, and if I turn on select whole bodies, I can select that solid, and depending on how this was all made, it'll actually help define all those features. So if I hit the check mark and hit next, my first feature becomes a facing operation. Zero type of feature, 0 depth of cut, and it's using the base rectangle. So I'll tell it we're doing facing. I don't need tabs for that. I don't need to change my posting page here, not using a different work offset or anything. And then let's go ahead and just say we're using a 2-inch face mill. Next. We'll do the adaptive path. The adaptive just means that it's going to maintain constant tool engagement if it can. 50% step over, climb mill, and actually let's go maybe 75%. See what that looks like. Single depth of cut, I'm not taking anything off. And a lot of times I will actually do this where I will just lower my G54 on my machine or my work offset to accommodate taking off 30, 40, 50 thou off the face of the part, or even just taking off 10 thou. So a lot of times I will program that 0 so that all of the rest of the code is relative to the face of the part that I'm cutting. Now my lead in, it's doing a vertical lead. It should be starting off the part. I'm okay with that. And it's going to do a vertical lead out. So we'll go ahead and hit next. Linking, it shouldn't need to link. It's an adaptive path, so it's going to try to maintain that constant engagement. And then you have your adaptive feed rates, which for this one, you could convert rapids to feeds if you needed, or change your lead in and lead out feed rate percentage. And then last but not least, we have our MDI here for this operation. So if you needed to, say, add in an optional stop after this operation happens, I can even go to this after operation, go to my line, and I can just add a raw text command. Technically, I can put anything into this. So if I add that command, you know what? I'm going to add two. I'm going to leave the raw text as a comment with the you can put anything you want here. Then I'm going to add another one for another line. So I'll go to after operation, add another line. Oh, you know what? I wanted to go to line and then add another line. So line goes underneath. Let's get rid of that other one. And on this line, I'm going to add a command. But this time, I'm just going to put in my M01. It's going to output as raw text, so it should just be code. Now, the next button takes me to the next feature, and you'll notice that the total depth is shown as 800 thousandths. Top of feature is 0, so I can assume that that's this pocket here. And if I had just drawn this on SolidWorks, I'd probably know that. So on this one, I'm going to do a pocket. I'll leave the profile finish in there, might as well. And we'll go ahead and hit next. I can't use tabs on a pocket, so I'll next pass that. We don't need this posting page. And then we've got our pocket. So let's go ahead and go with, you know what, I'm going to check the library. Let's just throw a diameter in there. Add from tool library. Let's maybe do like a 5/8 diameter. All right, so I've got my tool. I'll go ahead and hit next. Now I've already saved defaults to use the advanced pocket. The standard pocket, I found that sometimes it does a little extra movements. Still trying to narrow down exactly what that is, but the advanced pocket works great and has a lot of extra functionality, which we're actually going to touch on right now with this part. Step over, I'll leave it 50%, climb mill, and we'll go ahead and hit next. Now it's got no side allowance in here. I'm going to go ahead and populate something in there. Let's leave 20 thousandths or so. And I'm going to do this in multiple depths. So we're doing 400 per pass. Then we've got our leads. Now I'm just going to have this spiral in. And we'll do half of the tool diameter. And the angle of approach, let's go ahead and go with like 7 degrees. 3 is awfully shallow. Then we have our machine sequence, which we only have one part, so we'll hit next. Our linking, we don't really have any other groups, so this linking should be fine. And then our advanced feed rates, we do get more options here. And if you're using the advanced pocket, which is another reason I like to use it, you get the adaptive volume-based feed rate control. So you can minimize your feed rate, your max feed rate, based on the volume of material you're going into. So if you wanted to go down to at most 10% of your max feed rate while going into a corner, it'll actually scale a little bit. So what we can do, let's go ahead and say 25%. And I'm going to go back to the tool for this. And we'll go ahead and just set a base number of cutting feed rate of 100 inches a minute. So we can see how that applies. So you can see that scaling. So we'll just get back down to our advanced feed rates here. Now there's also a corner slowdown, which works a little bit differently. Then we have our MDI, which I'm not going to add anything else here. Then we've got our profile finish. Now this is a finish tool. I'm going to go with a smaller diameter. Let's say we go with 3/16. We're doing left compensation for climb. We do now have spring passes. That is new in this version. And now the way the spring passes work is I could tell it I want to do one additional pass or 2 additional passes. And then you have the apply lead prior to the spring pass or not. And you can see by clicking on this little checkbox, I'm changing that image. So let's go back to one spring pass. So I can see if I don't have this checked, it's going to lead in, go around, continue around a second time, and then it's going to lead out on this fourth move. If I turn this on, it's going to lead in, go around, lead out, come back over, lead in, come out, around. So I like to keep that off just so it doesn't lead out an extra time. Yeah, we have our post processor class there if anybody's curious about editing posts. Now our parameters, we're going to do this in a single depth. There's only about 20 thousandths on the wall, so we should be fine. Our lead in, now I am going to do a lead. Now we did add point and point blend in this version, but I don't have a point that I'm specifically going to select. What I'll do is we'll try to use that on the bottom. For this one, I'm going to go ahead and use circular. So it's going to do a right angle lead. I'm going to change that to tangent. And we'll do half the 3/16 for the length and radius. You can do math in every field in the BobCAD plugin, in case you didn't know. We'll maybe go to a 45-degree angle on that. Corner types I don't need. Machining sequence I don't need for this. I only got the one part. And then the advanced feed rates, the corner slowdown differs from the adaptive quite a bit. So this one, you have your min and max angle for the corner. The distance away from the corner you want to start slowing down, and then the feed rate that you want to slow down too. So just for this one, let's go ahead and this one's going to be a little easier to kind of see. Let's do 50 inches a minute. And then we'll say we're going to drop the feed rate 50%, an eighth inch before a corner. So you can see how that looks in the code. And then we have our MDI, which we're not going to use on this one. And then we have the next feature. So this one, I can see the top of feature is negative 800 thousandths, which means that it's at the bottom of the last pocket. And from there, it does another 800 thousandths. Now, a good habit to have, anytime you have a negative top of feature, I usually go to my rapid plane and add that value just to make sure that it's up over the part when rapiding, because if you have a wall in the way, you could actually collide. So just be aware. So we're going to do another pocket with a finish. Tabs. Don't need this posting page. It's already got my 5/8 diameter end mill. We're doing an offset pocket out. And you know what? On this one, I'm going to do adaptive roughing just to change it up a little bit. Step over, we'll maybe go down to about 10% step over. And we want no side allowance. Actually, let's put 20. Save my defaults. I don't remember changing that, but yeah. So we'll do multiple, we can do single depth on this one. The adaptive, when you're doing the radial chip thinning, which we have a white paper on our site, which I'll pull that up here in a minute if any of you want to download that to read more about the radial and axial chip thinning and how that applies and the formulas and all that good stuff. We have a lot of information for that, but this is technically made for a full flute engagement, full depth, but a very small step over. So we do want a spiral. We'll do about half, and I'll leave this one, we'll do about 7 degrees as well. Then we have our machining sequence, our links, our advanced feed rates, and our MDI, which none of that we need for right now. So we'll go down to our profile finish, and it's already got the tool I want. So we'll hit next. Got left compensation, single depth, which should be fine. Our leads. Now I'm going to try point. Now, sometimes this lead from center, when you have shapes that are not circles, are going to try to pull a different position. So we're going to see if this works out. If not, what I'm going to have to do is actually place points to lead from to use that. So if we don't get that working, I'll probably just do parallel. So we don't need the next few pages. We're going to go ahead and hit compute. So that computes all of those features. So within one toolpath wizard, I just programmed my entire part. And if I go to simulation, I can see what that looks like. So I'm going to slow it down just a little bit, and we'll go ahead and hit run. Now, like I said, the first facing is not going to take any material off because I didn't define any there. That doesn't mean that I don't have any there, though. A lot of times I do lower my G54 to face off at 0 just for these scenarios. We'll speed it up a little bit. Now, that 3/16 tool is probably a little too small to take out those corners, but we're not actually making this part, so shouldn't be a big deal. Now, you can see the adaptive's doing that very small step over, keeping the tool engaged as much as possible. Now, if you notice, it hasn't changed tools at all. It stayed with that 5/8 after the 2-inch. Now it does the finish, doing a spring pass. Then we've got the inside, and it does look like it lead in from center, so we're good on that. Now, what's really cool about the power of the Solidworks plugin. Now I'm going to have to remove the geometry for this pocket and reselect it. And I'm just going to say I'm going to pick this extrusion. Oh, come on. There we go. Now the reason I'm doing that is this pocket will not work. Well, now I gotta, to do what I want to do, it's not going to show this properly. Oh, and it didn't pick the geometry. That's odd. Should just by picking the extrusion. See, the sketch now is on the top of the feature. So I have to make sure that my depth comes in. It always does default to the feature parameters. And if it's on the top, it's going to default to a 1/2 inch total depth. All right. So it's doing the same thing. But the other cool thing about this, besides being able to just select a model and program it, especially if you have a quick, easy job, is let's say I just need to change this pocket and it goes from being a closed shape to an open shape. So if I go to my SolidWorks plugin, the features, let's go ahead and blank everything out. This is the status bar that I was explaining. You have your post yes no icon and your blank unblank that you can hide or show objects. And if something is blanked, you can click on a toolpath and it will show that toolpath. You can click on the geometry, it'll show the geometry selected, or feature will show what feature is selected. So let's go back to our SolidWorks feature tree. And if I expand this extrusion and edit it, and just say I'm going to drag this sketch out because it's not constrained, exit the sketch, it updates the model. So if I go back to my cam tree, it says the model geometry has been modified. Some machining features may no longer be valid. Do you want to auto update the cam tree? If I hit yes, now it should have all my same information, which it does. So I'll hit compute. And because I used an advanced pocket, oh, it's making me a liar. Because I picked the sketch, and that's why. Okay. The sketch is closed. Now it should let me pick that. What did this just do? Oh, that's interesting. It just doubled up everything I had. That is really bizarre. I will have to see if I can recreate that because, yeah, just changing geometry just doubled up all my facing. Oh, yeah, because of the feature recognition. It changed and modified everything in the tree when I should have hit no. And that's what I get. I just kind of click through it. But you can see now that automatically changed to an open pocket. Because that extrusion detail is open, it automatically knows that. Now, there are some other scenarios where that's not as simple to do. And that actually brings me to the next model. Now, posting your code for any of these, you're just going to right-click milling job and go to post. And that way we can see, oh, and I must not have the MDI blocks in my post for that one. So let me change it to a post that does. Which actually, let's just use the BC3X mill. That should have every MDI block. There we go. So at the end of the facing, we can see there's our comment that it is in brackets there. And then we have our MO1 afterwards. So that MDI does allow you now to go and put in pretty much anything you need. So if you run into, pallet changers, optional stops, all that kind of stuff that a lot of you guys have been asking for years. Now you can plug it in on every operation before the tool change, after the tool change, or after the operation. We can even go in and add and move stuff around for you and make custom commands so that stuff outputs where you'd like. Now, if I come into my operations tree, because of the way that I picked this, and I should have deleted my operations and started it fresh for that pocket, and that's my bad. But I can see the order of these operations. So there's my facing, there's my pocket, and I'm actually going to have that pocket next. We're going to disable this one. We need that profile finish. We need that profile finish, and we're going to disable these two. They're not even computed, so I'm not getting code for it, but those are the ones that it doubled up. So this is my operations tree, so I can see the order of these operations. Now, in some of this, you can go in and change the instances. Like if you have toolpath patterns, you can show those or not. Operation priority versus feature priority for the patterns. You'll have your same old settings you always had, the individual feature, individual tool per machine setup, and individual tool, just like you had on the old operations manager. You have your post and post selected. So now you can actually go in and say, I just want to take these two operations, and I just hold control to pick those two. And I could say I want to post the selected operations, and it's only going to give me those two. So additionally to the operations tab, we have the power that you can see your order of operations. You can toggle stuff on and off very easily here. You can see what order is happening, and you can even see the toolpath patterns. Now you also have the tool tree. So let's say I wanted to change that 3/16. Maybe that is a little too small for this. So if I replace that tool and I hit yes to replace it for every operation that's using it, let's say I want to go with a 1/4 inch. It flags all of those tools that says, hey, that's been changed. We need to update it all. So if I right click the tool, I can compute all of those operations. And now I have it all set for, which we don't need that one. That one's not. Now we've got our profile finish for the inside of that. All right. So, and if anytime during the event, if any of you guys have any questions, please just go ahead and ask. I may get to it right away. I might wait till the Q&A portion a little bit later, but we'll definitely touch on any questions you guys have. So if anybody does have any questions, just let me know. And actually, you know what? I'm going to do this last. The next part I'm going to open up, we actually have an assembly all defined for it. We do work in assemblies. Now I have this Kurt vise that I've made up. I've already placed my part in that vise, sitting about a 1/16 above the vise jaws, I believe. And you can see my assembly over here. I'm just going to go over to my cam tree, right click cam defaults, and go to new job. Now I've already made this extra machine that does not have any solid models so that we can have the table and everything show in simulation. So if you don't have Machine Simulation Pro, you're not going to see the models anyway. So if you define your assembly with the table, your vise, or your fixture, or whatever, all of that gets carried into simulation with you. So now I definitely want to pick my solid body so that when I go to the next page, it knows my stock is around that part. Now I do need to take care here because my Z is actually pointing away from the model. This was drawn in a perspective that Z is not the top. So if I change my size here, let's say I change my Y to 1 inch, it's adding the 1/4 and 1/8 inch to both sides. So now if I go down to enter origin, I'll go to Y, let's subtract 1/8 inch. And you can see that brought that stock down right up to the face of that part. Now I might want to take off 10 thou. So let's go ahead and go to that Y and just add 10 thou. Now my X is already to size. I already have it to size with the vise jaws there. And then the Z, this one, if I change the size, let's say I make that 2 and 800. Add 25 thou per side. You'll notice that it only added to the one end. And it's really easy for this to happen in SolidWorks because you're kind of free to draw wherever you want, where Z might not show coming off the part correctly for the stock definition. So I'm just going to go over to my Z, and we're going to add 25 thou. That should have shifted it down to the middle, which it is. So next page, I'll go ahead and pick my origin, and I'm actually going to use that corner here. But you'll notice my Z, Y, and X are based off of the CAD model position. So I'm going to click X-axis until it falls along that line, and then Z-axis follows along this line. Now they are pointing, Z is pointing the wrong way, and so is Y, so I'll flip my Y-axis, and now they're oriented correctly. Now make sure that when you are in this step, if you don't see these snap points pop up all over your model, it is because your views, the hide show, is set to hide sketches. So if you have sketches hidden, you're not going to see all this. So just keep that in mind. If you don't see those snap points, it's because your sketches are hidden. So click OK, and now I've got my part. Now I could do the same thing where I go in and tell it to just pick the model and go, but I'm not going to do that on this one. We're going to do this a little bit differently. I'm going to go to my machine setup, and I'll just start with mill facing. I don't need to pick anything. I'm just going to hit next. So I can already see it knows the total depth is 10 thou. Top of feature 0. I did put my origin on the top of the block. I could go change that, but I'm not too worried about it. So we only have a facing operation with this. I don't need the posting parameters. And I'll go ahead and go in with like a, this part's not all that big, so let's just go in with a 1.5 inch face mill. And we'll do zigzag. When you do zigzag, you're going to have this off workpiece and on workpiece value. Off workpiece is an additional amount from center of tool that you want to leave the part. So with a 1.5 inch tool, we're already coming off the part with off workpiece. This is an additional amount you're moving away from that part. So if you set this to 0, it is the same thing as on workpiece set at 0, and this is a percentage of the tool diameter to leave on the part. So if you just want to come off the full diameter, either one of these options set at 0 will do that. If you want to stay on the part, on workpiece, again, is a percentage of the tool diameter. If I said like 25, it'll leave just a little bit of the tool on the part at all times. If I want to leave the part at any bit, I can put that in here. You know, a 1/4 inch would be an extra quarter off the part. And I'm going to leave both of these at 0. We're just going to go with off workpiece. We'll go across the X direction. Let's do 75% step over, and we'll hit next. So I want no bottom allowance, single depth. I don't really need a lead. It's already starting off of the part. Linking, direct should be fine. And then we have our advanced feed rates and our MDI, which we're not going to use on this one. So there's my 2 little cuts. Now I want to do the pocket on the inside. So if I go to my machine setup, I'll go down to mill 2 axis, and I can do this a couple of different ways. If I go to select geometry, I could either pick the bottom surface of that pocket, which will give me all the information, or I can come over to the feature tree, go to that part in the assembly, and go to that cut extrude and pick that way. Either which way should give you the same information. So it is, top of feature is 100 thou, negative 100 thou. Total depth is 1/2 inch. So I'll hit next. So I'm doing pocketing. And I don't need these first couple pages. And now the tool is going to default to the 1.5 inch. Now in V10, you have either tool crib, or if I uncheck system tool, I can click this drop down and modify or go to the tool crib from here. So if I go to tool crib from here, it just brings me to the same window. Let's just go with, you know, that 5/8 seemed to be all right. Let's just go back with the 5/8. Where'd that go? There we go. Oh, and we didn't look at some of that code. We'll go back to that other part to look at deeper at that code. I forgot about a couple things. So I'm going to do offset pocket out since it's a pretty deep pocket. Save that pocket information. Step over, we're going to go back to 50%. Save that. Side allowance, I'm leaving 20 thou. And I'm going to do this in multiple depths. We're going to take this a 1/4 inch at a time. We will spiral, and I'll just leave that. We'll do the 315. Wrong way. There we go. And angle, we'll go back to like 7. Machining sequence, I don't need. Linking, as long as I'm on retract, I feel pretty comfortable between groups. Within groups, most of the time I do S-link or direct. And there is now this new minimize link. So if there's islands in the way, it will kind of change where it links to the toolpath to minimize that a little bit. But again, it just depends on the geometry, and some geometries it does not have any effect on. I've already found a couple of them. Advanced feed rates, we don't need on this one. And MDI, we're not going to use. So we got our finish. Now I want to say that's a 1/8 inch radius in those corners on the inside. So we'll go with a 3/16 end mill. Left compensation, maybe add a spring pass. Single depth of cut, it's only taking out 20 thou. And our lead in, let's just do a circular lead. Again, I like tangent myself, and maybe just do 100 thousandths length and radius, about 45 degrees. Under type, we got external and internal, we don't need to touch. Machining sequence are good on, and we don't really need the rest of the pages here, so we'll go ahead and hit compute. Then we've got our pockets. Now you can see because that 5/8 tool, it's doing a little too much, so it can't take all that information or all that pocket out. So I'm just going to go to my tool tree, and we're just going to change that. I'll just edit or replace that tool. We'll just make it 1/2 inch instead, or 3/8. Let's go with 3/8. And I can compute that toolpath from here, and it updates that operation. Now, I could have added my chamfer to that operation as well, but I know I have a chamfer on the outside. Now, if I'm going to run a profile on the outside, I'm going to have to do that chamfer separately anyways, because this is not the same as the rest of the profile. So let's do these pockets next. And if I go to machine setup, I'll go to mill 2 axis, select geometry, and now I just pick these 2 faces. This is another method for picking geometry. So I can see that is picked correctly. It's got my top of feature and total depth in there correct. We're doing pocketing. Now we don't need these first couple of pages. I'm going to go with that 3/8 end mill again. And this time I'll do adaptive with maybe a 10%. Let's do 7% step over. Again, I'll show you guys that white paper that you can download off our website before we're done today for any questions on the radial chip thinning and axial chip thinning. Now, one thing I have not pointed out is there's a link clearance when you're doing adaptive pocketing. This is how much it's lifting when it links that toolpath. Now, when it uses those links, just know that it's going to use your default maximum feed rate for the machine that you're using. So most of our default machines, I want to say they default to about a 500 inch per minute maximum. So in your code on a pocket, doing these adaptive paths, you'll see that 500 inch output on all of those linking moves. Otherwise, you'd be feeding it the same that you'd be cutting as. This one we will do a full depth of cut. And I don't need to do a lead because it should be starting on the outside of the part anyways. Machining sequence, we'll just go with closest. Linking, we don't have any options there. And we don't need the next 2 pages, so we'll get down to our profile finish. Now I'm going to go ahead and leave the same diameter tool, the 3/16, doing left compensation without a spring pass. And I'll do a single depth on this one as well, and maybe do a nice circular lead. I do like to go tangent into my leads just so it's not such a dramatic turn. Your machine doesn't have to stop before getting there. And then we don't really need the next 3 or 4 pages here. So I'm going to go ahead and hit compute. So there's our adaptive path with our finish. Now we'll go ahead and do our profile on the outside. Now the profile on the outside, all I need to do is go mill 2 axis, select geometry. And if I pick the main boss extrude because of the shape that I used, that should give me the profile I need. So it didn't. Let's go back, make sure I picked the right one. Yeah, I did, but it definitely didn't do it. So we'll pick the sketch. Now the sketch is on the bottom of the part. So that means it should be reading from the machine setup down to that section. So it's a depth of 760. And technically it's 750 with a negative 10 thou top of feature. Oh, and I made that 70, not 750. Just to make sure, I'll re-enter the info. Now this one would be a profile, but I really don't have a lot of material to take out. So I might do that as just a finish by itself. I don't need tabs. I don't need the posting page. My diameter is already selected. And I might even want to use that 3/8 end mill to take all this out. So if I uncheck system tool, now I can really quickly go in and grab the 3/8 flat without having to go to the tool crib. So we've got left comp. Single depth, there's really not a lot of material on the sides. And we'll do another lead in. Let's do a blended lead this time. So blended leads try to make this teardrop shape to accommodate the blending of the length of the lead and the radius that you're applying. So if I do 100 thou for both of those, it's doing 100 thousandths radius and then 100 thousandths lead out of that. And it makes that teardrop shape so it enters and exits the same location. Corner types I don't need. Machining sequence I don't need. So I don't need the rest of these. I'll go ahead and hit compute. Now, that default chain start point, if I left click on that, I can see that that arrow is going counterclockwise. So that means my left profile would be on the inside of that. So I need to right click default chain start point and go to modify. I'm just going to start it on the edge here and then reverse the direction. And I'm just clicking on the arrow to reverse it. I'll right click and OK, right click the profile and then compute. And you can see my little teardrop blended lead there. Now, last but not least on this thing, we have our chamfers. And I don't even remember what size I made them. So let me go back to my feature manager. Go to my part, edit, 16th. All right, so I made that a 16th of an inch. So we'll go to our cam tree, right click machine setup 1, and do a mill 2 axis. Now this one, I need to actually go in and select profiles. So I'm going to right click on this line there and go to select tangency. That picks all the way around. Do the same thing here. Pick tangency. Picks all the way around. Next, I should have both profiles, which that looks good. Now the total depth is reading that 16th, but we're actually going to have to remember what it is and enter it later on. So we'll use a chamfer. We're just going to use the chamfer mill by itself. And let's just say we've got a 1/4 inch. It's a sharp tool. So to change that tool, I've already made a 1/4 inch. I've pulled a 1/4 inch chamfer mill in. If now I uncheck system tool, I can click the drop down and modify that tool and get rid of that small diameter. So it's just a sharp point. Now my next page, it looks just like profile. You have your spring passes, your compensation, and you do have G41 and G42. I just haven't been using those today. Now I did get an error because it said that a small diameter tool of 0 can't be selected as a flat bottom tool. That is the default. So if you go in and modify the tool ahead of time, it's going to change this value, but it's still going to be defaulted to flat bottom tool. So you just want to switch to sharp, and you're going to keep getting that message until you do. So just keep that in mind. That's why you're getting the error. You're not doing anything wrong. It's just reminding you of what you're trying to select. Now it is a 45-degree angle. And then my cutter position, this is how far over we want to start to engage that flute. So most of these tools, if you're using an insert cutter, you're going to have a radius at the bottom. If you're using a sharp tool, a lot of them don't technically have a sharp. It's like a 2/1000 flat or something like that in a lot of these. So this is just a shift to move that tool over to get to that depth. And then we worry really about all the hard work. So put in your depth over here. We have a length, width, or depth that you can pick from. So if your print is just a width or a length, you can define it that way as well. And then you do have multiple depths. So if you needed to take that in like a depth of cut of 30 thousandths per pass, you can. Which I'm going to go ahead and do that on this one. We'll even turn on minimize retracts. Maybe do just a simple lead. Let's do we'll keep it on circular. We'll do tangent. All right. And then we don't need the last 4 pages here, so we'll go ahead and hit compute. And now I'm not seeing my chamfers, so more than likely they're on the wrong side. So I just want to right-click default chain start point, reverse, right-click chamfer, and then compute. And then there's my paths. So they actually look pretty good. I like where the lead ins and lead outs are for those. Everything looks pretty solid. So let's go ahead and check simulation. Now I didn't do this, and actually let's go ahead and close simulation real quick. Because what I'm going to show you is currently I only can show or hide my workpiece. My fixture was not selected as a fixture. So in simulation, I'm not going to be able to show or hide that. So if I close my simulation, underneath machine setup, we do have a fixture. I'm going to go ahead and reselect. So we'll just go ahead and pick these. Oh, it's not going to let me pick them that way. All right. It's essentially everything but the part. Which I think that's just about everything there, besides the bolts, which I'm not too worried about. I probably could have hid the model and then just picked everything else, window picked it, but now I have a fixture selected, so let's go ahead and simulate. And again, if anybody has any questions, just let me know as we're going through. So now my visibility, I could show that fixture. So in the simulation, I can actually see everything kind of going on. I can even have the tool move around or have the workpiece move around. So that's going to make my table move where the tool's stationary. If I set it to workpiece and I turn that fixture on, I can see it and kind of move around and see how it's working on that workpiece. Now you'll notice that it did a little different order than I set it to, because the machining order is dictated by the tool numbers. So it's trying to maintain tool numbers together. And it looks like I have a little bit of a gouge there. So let's check our simulation or our tool paths here. So if I make my workpiece hidden, you can see there's the gouge. So let's find out where that's coming from. So that's going to be on the pocket. So let's just blank the job. That's going to be this pocket here. And it's probably this finish. Yep, which I have it going right into that wall. So if I right-click default chain start point, I'll go to modify. Pick maybe the middle so it's a little safer. Okay it. And compute. So now I should have no gouges on that in my simulation. Yeah, you can see the multiple depths there to get the 16th. Now, if I have my workpiece on, I can see the difference between what I milled and what I've got, and it looks like it's pretty much exact. Now, sometimes the colors make it hard to see what's going on. So those colors can be changed. Down at the bottom, there's an analysis tab. If I change that to none, it makes it a solid blue model. So I can see my radius of tool for the finish is a little too big for these corners, but I'm okay with that. I think I can live with that. Um, but you can see in the simulation where it's deviating from the original size. And don't forget, if any of you guys have any questions as we're going through, please let me know. All right. Now this one should be done, but I do want to go back to that last file, and I think I actually closed it. I did. So let's take this one and use some of these feed rate control options. So we've already got this pocket, which this pocket has just square corners. So let's go ahead and edit this one with the advanced feed rates. We'll do the corner slowdown. So let's say I do 50% slowdown, 16th before a wall. And I'll even do that. Yeah, we'll just do that on the pockets. Now, the next one, let's say I take this pocket, and this one's going to be a little different. I'm going to use the adaptive volume based, and you'll notice now I get a minimum and maximum, not just the minimum. It's because I'm using the adaptive toolpath. That also gives you the radial chip thinning. So let's say minimum feed rate of 25%, and we'll set this to 100 just so it's easy to kind of see what we've got. So this first pocket, if I post, let's go ahead and bring it in the NC editor so it's a little easier to read. So I've got my plunge feed. It's down to depth. Looks like it never gets down to depth. Hold on, let me double check that feed. Ah, yes. Just so it's easy to see what we've got, I'm going to change these to pretty basic numbers. All right, so the first pocket we'll post, NC editor. We'll see what we got. So you can see it's entering at 50. When it gets down to depth, it goes to 100. Now this one may not scale much because it is just taking that little 10% step over. So I may have to adjust that for it to really give you an idea. But that one actually was pretty consistent. Really wasn't a lot of variation to that. Now, if we look at the other one, this one should, but it may not either because there's really not a lot of variation in those corners. Yeah, you can see it's sped up a little bit in some of those corners because it's a lesser volume than this the step over that we've defined. And it looks like my default machine has 600 inches a minute for the linking. 128, 103, and you could see where it's ramping up and going back down because of the volume that it's engaged with. Now the other one, I did it as a corner slowdown, right? Yeah, all corners. And they're not really corners, so maybe that's... Yeah, it's not slowing down. I'll try it on a profile on something square so that you all can see that. Because those radiuses in the corners, it's not really hitting anything. It's outputting a GO2 for the corners, so it's not getting a square corner to reduce from. All right. Now, again, if we have any questions, feel free to ask throughout the event. We'll touch on them as we go. And we're going to take a look at one last little part. that should kind of take up the rest of our day here. Let's go ahead and just close this guy. Not too worried about saving it. Now, the Launchpad linked courses in there. If you sign up for any of the BobCAD courses, this is actually a part that we used for one of those mill courses. So if you do sign up for Launchpad, you will see this one as one of the ones that we have for the BobCAD Launchpad. And that Launchpad is, if you go to our support site, you'll get quick access to it. Might as well take a second to talk about it for a minute. When you go to our support site, you're going to see the Introducing Launchpad by BobCAD. When you go to learn more, you're going to see the free courses, and that's the one that was linked there. You do have the Getting Started for V10. And then you also have your subscription bundles. Now, I don't believe we've released any of the SolidWorks ones yet. Now we're still working on those. However, all of the CAM that's in the mill fundamentals is still valid. It's still the same CAM tree. It's just the drawing portion you wouldn't really get a benefit of. But the free courses, we do have some tutorials in here. There are a couple of tutorials for mill, lathe, mill turn, and wire EDM, which is a new module for us this year. So definitely check these out if you're just getting started with BobCAD for SolidWorks. Very good resource. There's also our forum. So if any of you guys have any questions, you can go right to the forum. A lot of us will answer, on the weekends, at evenings, because we just never get away from this stuff. All right. So same as the last one, I'm not going to have a fixture, not going to do too much when it comes to that. We're just going to have the part here. So I'm going to go to my CAM manager. We're going to go to new job, and we're doing milling. And I'll just use one of our default machines if we decide to add anything like MDI or anything like that. So I'll select my solid body and hit next. Now this time the stock is right. However, I want my X to go along this edge. So what I need to do is the stock size is fine. I might just come in here and enter and make it, 6x7, just so it's more uniform. Maybe 6 1/8, 6 1/4, 7, and we'll make that 2. Now again, the Z, it only adds to the bottom. So if I need to add, 5/10 thou to face off, I need to adjust my origin position for that stock. So let's just make that like 850, just to move it up a little bit. Because this actually does have operations on both sides if we get a chance to get to all that. So we'll hit next. Then we've got our machine set up. I'm just going to go off one of the corners. Now I do want my X though to be aligned with this long edge. So I'm going to go to X axis, pick this edge. It's not going the right way, so I'll just flip it and then flip my Y to get the Z the right way. All right. Now, the facing on this one, nothing's really changed. I'm just going to go ahead and add it real quick. I don't need to select geometry when you face because it's already looking at our stock model. And it knows it's only going 10 thousandths down. Now, let's just go ahead with like a 2-inch cutter. Maybe 75% step over. Off workpiece should be fine. And maybe add a little bit, maybe just a 1/4 inch coming off. Single depth. Don't really need a lead. I'm already coming off the part. Linking, I can even do arcs. Now, a couple years ago, I did have a question about the linking on facing, if somebody could make them into a rapid move. Well, and you can't make them a rapid. However, if you set it to arcs and you're on zigzag, let's actually add a little distance to this. Let's say 1/2 inch. On your tool, give this arc slowdown. So if I say my cutting feed rate, and let's just use a basic number, 100. If my feed rate is 100, when I go to those radiuses, I might want to increase that 500%. So if I do a larger number here, when I go to actually post my code, because I have arc turned on, it's going to do a faster feed rate for those radiuses than the line moves that are actually cutting, kind of in a way making a rapid. Now I don't need the advanced feed rates or the MDI, and just for fun, let's go ahead and add that those two commands again. Oops, didn't mean to add that one. We'll add our raw text, and I'll leave that one as a comment. I'll add another line, then we'll add another raw text, and we'll make this one M01. There's no more next. We'll go ahead and hit compute. Now, if I post this one, what we're going to see is that when it gets to those arc moves, it's going from 100 inches a minute to 500 because I did a 500% increase. So you can kind of convert those to rapids if you need to. That's come up at least once or twice. And then we have our MDI block. You can put anything you want there, but I put an M01. And each of the lines within the MDI is one line of code. If you put everything on one line, it's going to just be a block of text. So keep that in mind. If you use different lines within the raw text block, you're not going to get line numbers on them. All right, so that first operation is good. Let's just go ahead and blank it. Now, a lot of times I don't care about blanking my stock, but I really do want to see through it a little better. So a few years ago, we actually added where you can change the transparency and set the default. So I don't use the Solidworks plugin too often, so I'm going to go ahead and set my default. I haven't done that yet. But now I can see the stock model, but I can see through it. So I'm still able to see kind of what I'm doing, which helps a lot. Now, the next portion would be doing this whole section out here, and that would be a pocket. But when you're doing a pocket like this, I can't just pick this face because that face only goes so far. It doesn't really know the area for that. So what we did is we have in our feature tree, we have a sketch that's hidden. Now that hidden sketch is the converted entities of this little plus sign. And then we have a construction line on the outside defining the stock area. It's really important that you have it as a construction because I can only pick for this particular type of operation. I can only pick for that pocket, the sketch. It would be, I don't think you could pick any other method. Now, even picking this sketch, I have to unhide it. I have to show it. And then I have to manually select the 4 construction lines on the outside. So I have my sketch and then the 4 construction lines. Now I can see that here. That's exactly what I want to see. It's not going to show this as dashed, but it's going to show that you have something there, which is what we want. So we're doing pocketing. And we'll go ahead and stick with that 5/8. Oops. We'll do offset pocket out, standard, advanced pocket, I'm sorry. Step over a 50 should be fine. 20 thousandth allowance for the walls. And this one we can do in multiple depths. I don't need a ramp because it is an open pocket. It's going to know that it can start on the outside by default. Sheeting sequence we don't need. Linking we should be good on. I can turn on minimize links, but I don't think it's actually going to affect this one. And then we got our profile finished. So let's go ahead and make this probably an 1/8 inch. I don't think I have a lot of leeway on some of this. So we've got our parameters or our patterns. So we're left compensation. Might as well add a spring pass. Now, when you do an open pocket, the profile only runs the solid edges. It throws away the construction lines. So it's only going to finish that little plus sign in the middle. I can do this one in single steps, but I'm going to do this in multiple. And with multiple depths, you have minimize retracts. So what that's going to do is when it leads out, it's going to just plunge to the next depth rather than retracting all the way up. Maybe do a right angle lead. Keep it simple for this one. Maybe make it 16th or so. Types I don't need. Machining sequence I don't need. So I can just go down to the bottom, hit compute. So that's doing that entire pocket. And you can see it's starting from the outside and milling away. Now I also noticed I could have done that chamfer at the same time. Yeah, and that's an 1/8 inch radius. So that works perfectly with that 1/8 inch tool running across that. Just wanted to double check my sizes. And I want to say I have only about an 1/8 inch width here too. But maybe not, maybe a 1/4. But I can add that chamfer to that feature. And that's one of the things about BobCAT that a lot of people don't realize right away is that BobCAT is a feature-driven system. So what that means is that everything I'm going to do to a geometry, I can pick that all at one time. So for this geometry, I'm going to do the pocket, I'm going to do the profile, but I'm also going to add a chamfer. I might as well get it out of the way and get it done. So I'm going to just skip down to the chamfer. Let's make it just a 1/4 inch 90 with no small diameter. I'm doing left comp. I want to do a sharp tool. My cutter position of 20 thousandths should be good. And then this pick bottom here, I can click pick bottom and pick the bottom edge, especially if I don't know the size. And it should give me the size here. Maybe do a blended lead, maybe make it something small. Don't need a whole lot there for that. And we'll compute. So that should just add that chamfer. So we'll go ahead and go to our BobCAD tab and simulate. Now, this just popped up. What this is currently, if I pause that, I am inside of the machine. So if you have Machine Simulation Pro, you're going to have this default machine. So let me go ahead and close this. So for any of you guys that have that, if you go into your machine setup and you change your work offset Z for at least the thickness of your material, which in this case we'll just say 3 inches, it will simulate with it sitting above the table. So now I'm not going to get that little collision when starting it. There's that 5/8 tool going in and pocketing all that out. All right, so that's a good start to it. Now I'm going to double check the width of that slot there. So I'm just going to go to evaluate and measure my 2 radiuses, and we'll do a minimum distance. So it's actually a 1/4 on this one. So that 1/8 I can have both run on both sides of that. So I'm going to go back to mill 2 axis. And you know what? Actually, I'm going to make that just a 1/4. We're going to change that tool. Replace. No sense in going with such a small tool when I can go to a little larger. And we'll compute. Oh, I just changed the chamfer mill. I didn't want to do that. I saw the 1/4 inch and I just changed it. 1/8 inch. There we go. Replace. Compute. Yeah, and I can even see that it offset that path. Now, when you're in the tool tree or the operation tree or even the cam tree, if you click on an operation, it's going to highlight that operation. So you can always kind of see where you're at. Even if it's blanked out, you notice if I click off the facing, it shows it or not, depending on if I'm clicked on it. All right, so now I want to do the channel on the inside. So we'll go back to our cam, minimize that feature and hide it. I'll right click my machine setup 1 and we'll go down to mill 2 axis again. Now I only need one edge because it's going to be cutting through that channel the same width as the tool. But my geometry, the top of feature and total depth are not reading correct. So I need to go in and pick top, which is going to be right down here, which it picked the wrong edge. So let's make sure it picks the right one. So that should be negative 850 because I had 10 thou at the top of the stock plus 750 for total depth. And then pick bottom, I can pick a bottom edge. So that's 125 thou. It just rounds it visually. Now I want to make sure that I add this type of feature value to my rapid plane. So I'll just make it a little bit over an inch. We'll do an inch and a 100th, just in case it needs to wrap it over for some reason. It won't crash through anything. And I really only need the profile finish. I'm just going to do a single pass. I don't need tabs, don't need the posting. If I uncheck system tool, I can go in and grab that 1/4 inch. So we're doing left comp, and I'll even add a spring pass to this just to make sure it goes through one extra time. Single depth should be fine. And then I'm not going to do a lead in or a ramp. I'm just going to let it run. So I don't need those last pages. We'll go ahead and hit compute. And there's my little channel down the middle. Now for the outside, and let's go ahead and hide this sketch so we can see what we're doing. We'll go ahead and hide that feature. And we might as well even hide our stock just to get it off the screen. Now we need to do the bore down the middle. So I'm going to go to machine setup 1. Now I might drill this first and then mill it out. So let's start with a drill because I want to say that's a 2-inch diameter. Now I'm not going to drill this at 2 inches, but I need to select just an arc or the cylinder on the inside just so that it knows a depth, which actually in this one, it didn't pick up the depth. So let's say the diameter is going to be 750, and then the bottom be the bottom of this model. We'll try to go all the way through. Now, if you have a workpiece selected, you will see your geometry in this little window with this little orange preview or pink preview showing the relative toolpath feature that you have defined. I only have the one hole, so you're only seeing one of those. Next, so I'm going to do a center drill and drill. Next again. Machining sequence, I'm not too worried about. Posting page, I'm not worried about. And the center drill. So I'm going to just leave it on the number 5. That's what we default to. If you go to Tool Crib, we do have a lot of, I'm running out of resources apparently. We do have a lot of spot drills and center drills already defined. So if you need to find one we don't have, you may have to add one. So next, so the depth, one of my favorite parts about the center drill, and it doesn't really matter for this one, but I'll mention it anyways. Your depth can either be defined by just a straight depth value, or you can define a center diameter you're trying to achieve. So if I know that this tool is, it's almost 1/2 inch, I can say my center diameter I'm trying to get is 1/4. It changes my depth to accommodate that. And we even now have pecking for center drill if you ever need. MDI, which I don't need in this case. And then we've got our drill. So it's automatically defaulting to a 750. If you need to change anything, you uncheck system tool and then click the drop-down menu and click modify tool. That'll let you change the point angle or whatever else you need. Then we have our effective depth, which you'll notice that's 50 thou deeper than what I defined earlier. That's because whenever you have a through hole defined, we add 50 thousandths to the depth of that hole, just to clear. And if I uncheck system or the use cutting conditions, you can see that the effective depth is to the shoulder or the full diameter of the drill, and the overall is to the point angle. And we do have pecking and fast peck for staying in the hole or retracting 100 thousandths above. We'll do fast peck on that one. And then our MDI, so we don't need that. We'll go ahead and hit compute. All right, so now we've got our hole, and now I need to mill that out. So I'll blank my feature, minimize it, go to machine setup 1, and we'll go down to mill 2 axis. So select geometry, and I'm just going to pick that arc at the bottom, because essentially that's all I'm cutting. So the total depth, I'm going to go ahead and pick bottom. Should be this bottom edge there. I'll go ahead and hit next. We're doing pocketing. And really, I'm only doing pocketing because there's just that little bit in the middle that hasn't been removed. And actually, you know what? Let's do it as a profile rough. I'll explain why here in a second. So we don't need tabs. We don't need the posting page. And I've already got the quarter, but I'm going to go with the 5/8. So now the pattern for this, there's a couple options. I have a 2-inch hole, and I've only done a 3/4 inch hole down the middle. So I need to plunge in the center and then mill the rest anyways. So if I turn on side roughing, I have 1.25 inches remaining. And actually I should divide that in two because it's per side. And then let's say I want to do 3 passes. Next. Now, because I didn't do a finish, I'm going to take the side allowance and make it 0. Do this in multiple steps. When you use multiple depths now on side roughing, you get sort by slices or passes, zig or zigzag. Same as the method, you get a zig or zigzag method on the side roughing now. So I'm going to do multiple depths, and we'll set it to maybe, I don't know, 400 per, so 350. I'll turn on minimize retract, so it just retracts and then or leads out and then plunges to the next depth. And I'm going to tell it to sort by slices. So slices should be one step over all the way down before it goes to the next step over. Passes, I believe, and I could be wrong, I might have this backwards. We'll have to see. Passes should be just stepping over and then going and stepping down to the next steps. Now on this one, I am going to use point and lead from center, just so I don't have to think about it. It should just be able to plunge right in the middle. And I don't need the rest of the pages, so I'll go ahead and hit compute. Now, if I go in and bring that tool in, the drill, if I right click on the drill and go to backplot, I can see how much I'm actually cutting relative to what's there. So I could actually make that 2 passes and it'd be all right. So let's do that. Let's make that 2 passes. And a lot of times too, I'll even make it, another way you can modify this is if I say I have 3 passes and I have a 1/2 inch stock remaining instead, it adjusts and it avoids more of the center. So by changing those numbers, you can essentially avoid the center, but you can also do an open pocket on the inside. I just don't want to go through and add all the sketches and all that stuff. So I use side roughing when I'm doing something like that. So now I think that's almost everything on this side. Let's go ahead and simulate it. I think the last thing is just going around and doing the radius and then flipping it over. And again, if anybody does have any questions, please let me know. Love to hear feedback from anybody. Now, it did leave a little boss in the middle after drilling that. And actually, I probably didn't even drill it yet because of the way that this is set up. So I need to go to my machining order and make sure that it does the drill before it does that 5/8 end mill. So I'll close my simulation, go to my operations tree, and I want to take my center drill and drill, and I'm going to move them up. So right after the facing, I don't really see any reason not to. Then it's going to do the pocket, then the profile in the inside, then the finish on the top, and then the slot, and then the chamfer. All right, that looks pretty good. Now it's doing it in the order that I want. All right. So now I kind of want to mill away everything on the outside just a little bit, but not too much. Like I'm only going to do a little profile around, maybe a little ways down, not all the way through, just so I can get the radius on there. Because this is something that I would need to flip over. So I'm going to go to machine setup one. We'll go down to mill two axis and select geometry. Now this is another scenario where I want to just right click on an edge and go to select loop this time. And when you do loop, you're going to get this little yellow arrow. The blue line is the loop you're going to get. So I would just want to reverse that. And the loops that I'm going to get don't work out for this. So I can't use that. Let's see if it'll give it to me. No. I'm just going to have to select each one. I could convert entities and make a sketch, but then that adds more sketches to have to deal with. All right. So there's my profile. Top of feature is 0, but technically we're milling from here. And then the bottom, we're not going to go all the way down, but I'm going to tell it to go to the bottom. And then I'm going to just reduce that a little bit. So that's 3/4 from, or that's 1 inch from there. Let's just make it 3/4. We'll do this as profile. I can do this as a rough and finish. That should be fine. I'll go and grab my 5/8 end mill. Doing left compensation. I could do side roughing on this, but it's going to give me a lot of air cuts. I'm not too worried about having the rest of the stock fall off. That's going to happen on the next side anyways, so I'll leave that as is. Side allowance, I'll leave a little bit of material and maybe do this in a couple depths. And we'll tell it to minimize the retract so it just plunges to the next depth. Lead in, we'll keep it simple on this one. We'll just do it right angle. If you're using system compensation, you don't have to go crazy with the length. Corner types, we don't need anything there, as well as these other pages. So we'll go ahead and skip past those. And then we got profile finish. Now I'm going to use the same tool. So I'm going to uncheck system tool, click this drop down and grab that 5/8. Why did that? My resource, yep, I thought I was going to see that happen. So my SolidWorks is running out of resources. I just crashed. I apologize. Hold on, bear with me 1 second. Yeah, hopefully it has a little bit of backup on that one. I didn't save throughout, so we'll see what it has stored up, but it's trying to send the error report now. This is usually when we do a little bit of the Q&A. I was just going to kind of continue with that model, but if any of you guys have any questions, just let me know. Typically, this is when we do the Q&A. I usually do about an hour and a half worth of content, and then we kind of do some Q&A, but we'll just continue on this guy as soon as I'm able to get it open. Just waiting for Solidworks to do its thing so we can reopen it. If anybody has any questions, just let me know. Surprised we haven't had any questions at all, not even a hello or nothing. Well, if anybody's there, if you have any questions, let me know. We'll be here for a little longer, still trying to reopen my SolidWorks. All right, now we might be able to get that back open. All right, I don't think it's going to save any of the stuff that we had done. That's all right. Okay. So I should be back with everybody here. As you can see, there's nothing on it, but my add-in is not loaded. So let's go ahead and turn that on. That's what I thought. Yeah. So we'll just go ahead and start the job. Use the basic BC3X mill. Select my workpiece and we'll continue. So again, I'll change my size a little bit, 6¼ by, let's say 7. Enter origin, and we'll just bump this up just a little bit. Maybe make it 800. We'll just take 5 thou off. Next. And this time I'll just put the origin in the middle, and we'll rotate our X. Perfect. All right. You know what? Let's not do the facing. Let's just bring this back to... That way we can save a little bit of time on all this setup. All right. So we'll go ahead and do our mill 2 axis. We'll do that pocket. So again, this is the one where I have to go to my sketch. show it, because if I don't show it, I can't pick these dashed lines. All right, so we've got 750 depth, which is what I want. We'll do pocketing. We'll just kind of breeze through this, get back to where it was. 625, offset out. Side allowance is in there. We'll do a couple dips. That should be good. We don't need to ramp because it starts on the outside. Finish, we'll go with our quarter. Let's do right angle lead just to get all this back on there so we can do the other side. And I won't worry about the hole in the middle. We'll just kind of pop it over the other side and just do the other stuff I had planned. I wanted to get to a couple other things. So I will do the slot still. I'm still going to do that one. So we'll pick that guy. So pick top, it's going to be that edge. And then pick bottom, it's going to be the top of that hole. And I'm just going to do a profile finish. It should default to the 1/4 inch because that's the only finish tool I have. We're doing left comp. I'll maybe do a spring pass on there. Single depth. And I'll just do a vertical plunge. So I can hit compute. So I've got my profile in there. I've got all that in there. I'm not going to worry about the chamfer and such. Now, I have enough where we could flip it over and reasonably kind of look at the other side. I'm not too worried about the radius and all that. And let me make sure I hide that sketch again so I don't have to stare at it. All right. So to put a secondary machine setup on the bottom of your part, so I need to flip this over and set it on this side. So I'm going to right click machine setup 1 and go down to additional functions and add a setup, insert setup. So this setup is still using the original CAD origin, but if I come in and right click on that setup, we'll go to edit and I'll pick right there. I'll tell it my X axis goes along one of these lines and I should be able to flip that. And now my X, Y, and Z are pointed in the correct orientation. Now, typically I would have had to face this side off, but I can't do that now because I don't have anything to face. Well, I can, but I'm not too worried about it. What I really wanted to show is the hole recognition. So there's a couple different ways you can pick holes. And I know I'm finally getting to the holes, but I can go right to mill drill hole or mill counterbore hole. And when I select my geometry, I can pick the counterbore and the pattern, and that defines all of it. And that's a really good way to define everything. And if I go to the next page and click in here, we're going to see, because I selected my workpiece, we're going to see where those holes are and where the counterbores are relative to the hole. So just by picking the features, I can do this. Now, another method to pick holes, and this is something that was first introduced in the Solidworks plugin, is the hole recognition. So hole recognition, I can pick a solid model, hit OK, and it defines all of the different hole diameters. So I know I don't need that one. That's that slot on the other side. I know I don't need the 2-inch hole in the middle. And it's just defined my 1/4 inch, 3/8 counterbore depth is 250, and it defines everything. If I hit compute, it's just defined the whole entire operation. But that operation is based off of my knowledge base. So you can see it's doing center drill, drill, counterbore drill, which most people are not using a counterbore drill. Most people are going to go in there with a 1/4 inch end mill and run that. So you can either change this feature, but if I delete it and I go to my knowledge base and say for a counterbore hole, I want to say if the counterbore is, let's say less than or equal, say less than 250, and it does counterbore drill. I'll hit save and OK. Now I should be able to go to hole recognition, pick my model, hit OK. Disable the 2 features I don't want. Cute. And now if I look at that feature, it has, oh, it didn't even do the counterbore. Oh, I know why. Because I didn't define it fully. I should have just left this the way it was. All I really need to do is add chamfer mill, or counterbore mill, sorry, instead of counterbore drill. Because I just removed it, it just didn't do it. All right, so I've got that defined. Let's just double check. Counterbore mill, any diameter, it's going to do the counterbore mill. So hole recognition, select my model, disable the ones I know I don't need, and hit compute. And then I've got all my holes defined, and it should have my, it still did a, no, it did a counterbore mill, but let's see the tool, it tried to use the 5/8. So we'll change that to the quarter. So we'll do system tool, 1/4 inch, and that's the finish tool. So you do have to double check the tools that it uses for those counterbore mills, but typically if you don't have any tools defined, it would have automatically defined to a 1/4 because that's the size of the drill. Now from this side, I might want to mill out the whole entire, outside shape, maybe this pocket. So let's start with the pocket. So I'll do mill 2 axis. And if I just pick that star shape, it should have everything I need. It should know the depth, the shape of it. I don't see the island in the middle, so we're good. We're doing pocketing. Where I can still go with the 5/8, but I might need to go in with a smaller diameter afterwards. So let's just keep it with these default tools and then see what it looks like. Leave 20 thousandths on the walls, single depth. And really, I could just go down to the end and just make sure I have a lead in on my profile. And compute. So if I go to simulation now, and let's just might as well go ahead and save since I ran out of resources so fast earlier. Now it's going to run both sides because I told it to, but the machining order again is still up here. So I can see the machine setups it's using. So it's doing machine setup 1 and then going to machine setup 2. All right, so that looks good. I'll go ahead and exit simulation. Now I may want to go back to the top and say, well, I'm going to go ahead and add in that stuff that I didn't do just to save time. So let's go ahead and add in a mill 2 axis. We'll see if we can't pick the loop around this part, which it looks like it did. Total depth is 1 3/4. We'll do a profile. Yeah, we'll just do profile finish. Now I want to uncheck system tool, go to my drop down menu here and grab that 5/8. Left comp. I don't need any of my parameters here, but I might want it to not go all the way through. So let's maybe do a right angle lead. Currently, if I hit compute from this top side, now we don't see a toolpath, but it is going in the inside there. So we'll reverse direction, right click the profile finish and compute. It is going all the way down to the bottom, and I may not want it to. I might have material I'm holding on to. I may be able to do that. That's all just held within this feature parameters. So that's wrong one. This one. That's all within your feature depth right here. So if I go 1.5, it's going to leave a 1/4 inch. So if I'm holding on to a 1/4 on the other side, I still have enough clearance. Then on the other side, I could add my profile to that one. Now I do also have a corner round here, but I don't know what that radius is. So if I just click on an edge, I should be able to get a piece of information there. It's an 1/8 inch radius. So I'm going to go to machine setup 1. Actually, let's go to that feature. Add a feature. And really, this top of feature being 0, it's feeding from all the way from 0 down. So I want to click pick top and just have it start from here. And then I'll just leave 250. Oh, no. Total depth from there is going to be 1 inch, I believe. Yep. So we'll make that 750. And on the strategy, we're going to add the corner rounding. So I don't need to change anything with the first one. I might need multiple depths, but other than that, really don't need to change anything. It's the secondary one here. So the corner rounding tools are pretty particular. You have to define it exactly the way it should be. Otherwise, it won't resolve itself. You can't actually make the tool. So I'm just going to pick one from the library that has the radius that I'm looking for. That one's awfully large, but let's go for it. Now, this one does have a small diameter, and that's one of the things you're going to have to look out for. Yeah, it does have a small diameter at the bottom. Now, at first, it starts out looking just like profile. You can do everything you can do with the profile rough except for contour ramping. Now, the depth is actually based off of this value here. So it's from that top of feature. So that total depth of 125, it's actually 125 here, should be correct. We'll just throw a radius on here for a lead in. Let's do maybe tangent. Maybe do like an 1/8 inch lead in, lead out, 45 degrees, and compute. Now, more than likely, that's going to be on the wrong side of the line, but let's double check. Nope, it is on the correct side. Now, I may want to add that chamfer to the top there. So let's go ahead and just go up to that feature, edit, machine strategy. Now, I want to highlight profile finish and then add chamfer mill. Now it's going to be at the bottom. So we'll grab a 1/4 inch, no small diameter. Now I'm going to get that error again. That's okay. I just want to click sharp tool and it fixes that. And pick bottom. We'll just pick the bottom edge of that chamfer. Maybe a right angle lead. And then compute. So it now adds that chamfer to the top. Now, if I go to my operations tree and extend this out a little bit, I can see that it's doing all of machine setup 1 and then machine setup 2. So that's ideal. That's what I want for this scenario. But you do have the other options here. So there's individual feature, which puts it in the order of the tree. You have individual tool per machine setup. So it's going to jump between the two setups if it can. And then individual tool. Actually, an individual tool will jump between machine setups. Individual tool per machine setup does one completely before the next. And it looks like it's doing everything kind of the way I want it. So let's double check simulation. And we'll minimize this up a little bit. And now we've already seen a lot of these first operations. So I'm just going to go ahead and skip to chamfer mill. Now I don't like it leading in right on that corner, so I might want to change that. But the radius and everything else look pretty good. Now, we'll be here for another few minutes, be here for questions and answers if anybody's got any. Thank you all for showing up today. I believe next week is another SolidWorks day. I believe they're doing I believe we're doing the 3-axis plugin next week, if I'm not mistaken. Let me double check that. And if any of you don't know how to find where the events are, if you've maybe gotten it through an email or you don't know how to sign up for them, if you go to training under BobCAM support, you have the virtual training schedule. Today we've got the 2-axis cam. You can even watch it from here, which you can see that I'm watching it live. Mute myself so we don't hear ring doubled up. But next week we have the 3-axis standard and then 3-axis pro after that. So keep a lookout for more events. We'll be here for a few more minutes if anybody has any questions. And thank you again for coming. Until next time. It doesn't look like we've gotten any questions. We'll probably shut it down here in another 5 minutes if we don't hear from anybody. Again, thank you all for coming out today. Until next time, if nobody has any questions, we'll see you then. All right. So it doesn't look like we have any questions. So I think we're going to go ahead and shut everything down for today. Again, thank you for coming out today. Until next time, we'll see you then.